What is gravity? In physics, gravity is known as the force with which the Earth attracts all bodies towards its center. This force generates the acceleration that falls on the objects that are brought to Earth. The gravity measurement value approved by the International System is 9.81 meters per second squared. As such, gravity is one of the four fundamental interactions observed in nature. In this sense, it is responsible for the movements observed in the universe, such as the orbit of the planets around the Sun or the Moon around the Earth. In addition, it is thanks to gravity we have the sensation of weight. Likewise, gravity is the concept in field of physics that explains the universal attraction of bodies based on their mass. Differences between mass and weight. Mass refers to the amount of matter that an object has, but weight refers to the force of gravity acting on an object. Mass is the amount of matter that an object has. It is a quantitative measure of a body's resistance to acceleration. We can see it as the resistance of a crockery on the table when the tablecloth is pulled out. Weight is a gravitational force exerted by the Earth or any other celestial body on an object, which is equal to the product of the object mass and the value of the local gravitational acceleration.
When we have a system that is at balance, we have to know that there is presenting a torque and a rotational equilibrium. For this, we have to know that a lever arm is the perpendicular distance from the axis of the rotation to the line of action of the force, which determines the effectiveness of a given force causing rotational motion. Also, we have that the torque is defined as the ability of a force to rotate an object, and it's given by the force and its lever arm. And the question is, torque equals to force by the lever arm.
These are some of the objects that we use as weights: the sphere, the dragon necklace, the neodymium magnets, the ring, and the spinning top. We also use a Jenga block. To build this experiment, we decided to use 3 wood bases: a wooden stick with a mark each centimeter as an axis, the weights mentioned before, the Jenga block, the sphere, and a pulley to reverse the weight of the neodymium magnets and obtain an upward force. For the second experiment in our prototype, we decided to use the same 3 wood bases, the same axis with the marks to establish a balance between the weights. One more time, we use a pulley to obtain an upward force with a spinning top, a necklace, and a ring. In addition, we use some threads to hang the weights from the axis.